they need to have opposite ability because we have electrophile carbonyl compound, then it will react with anything opposite, which is nucleophile. Okay, and because it contain C double bond O, which kind of similar to C double bond C of alkene. That's why the type of reaction will be addition. Okay, so at the end of the reaction, you end up with new functional group depend on the type of nucleophile. And also, sometimes, most of the time, you get a hydroxy functional group, which came from the original oxygen of the carbonyl. Okay, so the mechanism divide into two possibility depend on how strong our nucleophile. Okay, if we use a strong nucleophile, the reaction will start by nucleophile react with carbonyl carbon forming a new bond. It means that two electron will delocalize to oxygen atom to maintain four bond of this carbon. Because if it's not delocalized or moving to oxygen, it will form five bond, which is not carbon atom forming bond. Okay, so before the products will be formed, or the atom will try to make themselves become neutral. In this case, we have oxygen, which still carry negative charge. So usually oxygen will protonate proton from maybe the acid, the water, or the alcohol, the medium that we use. Okay, so at the end, form double bond structure. It will form or single bond because it's addition at the end of the reaction. It so will be a single bond. Another case, when you have a weak nucleophile, it's not very difficult to make the reaction occur. So the only thing that you can do is to add acid to make our carbonyl group become a bit stronger. Then it can react to each other. So we call acid catalyzed nucleophilic addition. Okay, so it start by because right now we kind of putting the acid, so in the solution it will uh, break into proton with positive charge. So when you have a positive charge, it means that oxygen with lone pair electron will react first. Okay, so when you get oxonium ion, which means oxygen that carry positive charge, and it have three bond, which is not common. So lone pair electron will move up, and you end up with positive charge carbon. Okay, so as we mentioned before, between single neutral sp2 and charged carbon. So this one becomes stronger starting material. So now your weak nucleophile can react with the carbon. And something that always happen as well when you have neutral nucleophile. After forming a bond with sp2 carbon, it ends up with positive charge. So you have to get rid of usually hydrogen to form a neutral one. So in the system, if you have acid, you have something else that carry lone pair electron, such as water or alcohol if they have oxygen. So it will protonate proton to make the nuclear O5 become neutral. Okay, so this is a possibility of the mechanism of nucleophilic addition. It depends on nucleophile. Okay, so we also mentioned about the reactivity of carbonyl compound. So aldehyde are more active than ketone, and we have two explanation. First one is steric effect, okay, and second one is electronic effect. Steric effects mean because ketone have a bigger R group, so it's very difficult that nucleophile will react with carbon. Okay. Electronic effects mean because R group is considered as a electron donating group, so it's helping donate electron into this carbon. So it's make carbonyl carbon of ketone become less active. Okay, so I give you a trend of the reactivity. Okay, so I also give you some head start. I hope yesterday you get a very good result of your laboratory. Okay, so first reaction that we're talking about is oxidation of aldehyde. Remember that only aldehyde is active enough for some type of oxidizing agent. However, it's no oxidation occur for ketone, okay, because its structure is a bit stable, so it's not active. So we have three possible oxidizing agents. First one is tolerance test with a tolerant reagent, which is silver ammonium hydroxide. Okay, so it used to separate between aldehyde and ketone. Only aldehyde will give a mirror image of silver. Okay, the second one it's a bit weaker than tolerant test is Benedict test. So it used to identify between aliphatic and aromatics aldehyde. Only aliphatics will active enough to be oxidized by this reagent. Okay, and the third one is testing alpha hydrogen on alpha carbon, and it will form the yellow precipitate of CHI3, which is iodoform. So it used to identify any structure that have this group in it, which is alpha carbon and alpha acidic proton. That's why it will form iodoform. Okay. The second one, I did give you guys an example of nucleophilic addition when the nucleophile are considered as a strong one. So first one is reduction. Your nucleophile is hydride. Okay. The second one is organometallic reagent. Your nucleophiles group on them. And the last one, it's cyanohydrin from nitride or cyanide. This one is in the salt form usually. Okay, so we learn about that one. So this one today, last time I did start with first weak nucleophile, which amine. Therefore, in the slide today, we will start at slide 42. Okay, let me check. Okay. So we did start with primary amine, and today we will finish secondary amine and also alcohol, which are considered as a weak nucleophile. Okay, so let's start our uh, new knowledge today. The addition of amine, I did give you guys an idea. You're gonna learn about whole story of amines later with Ajahn Prabhupada, okay? But I'm just introduce you guys that we can divide amine into three groups based on how many are group forming a bond with nitrogen. Okay, if you have one R group, then it's primary. 2R group, secondary, and 3. Some people might remember it in the way that if you have two hydrogen, primary amine, one hydrogen, secondary, up to you. No hydrogen is mean tertiary. Okay. So last time we start with alkyl halide react with primary amine. Okay, because it's the weak nucleophile. That's why it's have to do it in my acid or you adding acid as a catalyst. Okay, the first intermediate that you guys gonna get is called carbinolamine or carbinolamide. Up to people. What's carbinolamine? Remember this carbonyl, carbon. This is our carbonyl, carbon. But right now it contains N amino group from amine and also hydroxy group from previous oxygen. And because the reaction is occur in an acid, hydroxy group is active to an acid, so it will form a living group, this one. That's why it's easily to break as a water molecule. Okay, so what happened? I just explained this already, but we're gonna go through it anyway. Okay, so lone pair electron on nitrogen will form double bond with this carbon and also kick water molecule out. That's why you get an imine at the end, which is from C double bond O to C double bond N. Okay, so today will be an example that we're gonna use secondary amine. Okay, for secondary amine, it's also occur as shown in slide 43. Okay, so it's gonna form intermediate that's named as carbinolamine, which one bond it's bond to uh, N amino and hydroxy group as usual. Okay, but at the end of the product will be what we call enamine. Okay, enamine means double bond that attach to N nitrogen atom over here. Imine means C double bond N, but in this case C double bond C and N. So why is that happen? By the way, the words enamine, okay, N come from alkene and amine. Okay, that's why we call enamine in this case. So let's have a look at the mechanism a little bit. Okay, I'm not going to go through it in detail, but I'm going to show you from, sorry, from this one. It's fine. Okay, from a start, nitrogen as a nucleophile react with carbon, lone pair electron up. This is the normal nucleophilic addition. Then we found this portion become positive, oxygen become negative. So it's quite straightforward. You can have another amine. Okay, another amine will protonate one proton. Okay, so now you get neutral nitrogen. And this negative oxygen will protonate proton as well. So it forms neutral carbinolamine or neutral. But as I told you, hydroxy group in acid condition, it's always carry on by two lone pair electron protonate proton, forming molecule of water. And water is good living group. It doesn't need to bond with any atom. It can be a single water. So what happened? Again, we have lone pair electron on nitrogen. It will move to this carbonyl, forming double bond. Okay, forming double bond. And also kick water molecule out. So here we go, another important factor. Now you get nitrogen with positive charge. In order to form a final product, how we gonna make it neutral? Because on nitrogen of secondary amine is no hydrogen left, so they use the hydrogen on carbon instead. Okay, so we have two possibility carbon over here. That's why it end up with enamine. Okay, right. So let's see the example. This one. Checking out your compound is ketone, and this is gonna be the position that everything happened, not other way. Checking your reactant, nitrogen with one R group, two R group, so it's secondary amine. Okay, my acid. So it means it's giving protonate proton. So it's usual because amine it's not strong nucleophile. So always has to be with base. So you end up with enamine, which is the structure of C double bond C and N. Okay, so this come from this amine and this N come from carbonyl, but sharing uh, double bond. Why sharing double bond? The intermediate will be okay, similar to this one. How are we going to make nitrogen become neutral? It's impossible. So we have proton at alpha carbon that easily breaking to proton. Okay, so this one, for example, breaking off. When breaking off, it means that they didn't take two lone pair electron. They just take off with hydrogen. So this two lone pair electron will move to carbonyl carbon, and double bond electron will move back to nitrogen. That's why by this reaction you get the product of then they become neutral and double bond here as an enamine. Okay, so second example, also an ketone and secondary amine. Because when you look at nitrogen, it's bound to one carbon, two carbon. But this two carbon, it's joined together as a ring system, but we still consider it as a secondary amine. Okay, so it will form, if you cut this N, it's mean amine, and this one, it's mean ketone. Okay, so you have to be able to work it out how it's formed. Okay, so in summary, again, the products of primary and secondary amine react with carbonyl compound will be different at the final state of the mechanism. Okay, for primary amine, because it contains two hydrogen in the structure. First step is already lose one hydrogen. You can get back to slide 43. In second step, they still have one more hydrogen left. That's why water protonate this proton and form neutral nitrogen of imine. Okay. For secondary amine, because this one have only one hydrogen and it will be removed from first step of reaction. That's why in this situation, water then have to protonate acidic proton at alpha carbon to form enamine in this case. Okay. So this reaction is very uh, important reaction. We call it masking reagent, okay? Because you can form imine and enamine. And when you add more acidic water, it will change back into the starting material, okay? It's quite straightforward for imine. You just cut in half. Okay, so first half upper will be amine and lower part will be carbonyl. You have to work out the neutral compound. This one as well, you still cut half of CN bond. Okay, and then you try to work out the neutral compound. Masking reagent mean in real condition, you might have more than one functional group, but you want to do some experiment that you don't want carbonyl group to change, yet you just change the carbonyl into imine or enamine. And then you start doing some reaction, and at the end, you can remove mask, and then you get the starting compound. I'll give you the example later. Okay, so let's try to do some exercise by this one. I'll give you a minute to work out this one. Okay. Anyone get the result yet? The question is, what's carbonyl and amine? So it means that you have to give two answer in each one. Form by hydrolysis. Hydrolysis means react with water. Okay, so you have to think about it. Maybe it's a reverse reaction of something. So first of all, identify your compound of question. So can anyone tell me what type of compound in question one and question two? Which one is imine? Which one is enamine? Which one? Number one.
Imine.
Number one is imine, and the second one is enamine. Okay. Well, then, if you understand and remember, so you should know that it's two compound making imine, which carbonyl and amine. So as I told you guys, you just cut in half between C and bond. Okay, and write down what's left. If you don't really have a clue, just write down first. Okay. Everything that is not involved in it, just write it down. Okay. Just straightforward one. But you know that one of your compound will be carbonyl. Then this carbon will have to form double bond. Okay. Another one is imine. You have nitrogen with R group, but nitrogen usually carry 3 bonds. So we have 1 bond R group, then you have to put hydrogen at the end. So here you are, your compound. Okay, can you guys do second one based on what I try to explain, please? Which one? Oh, sorry, guys. CN, double bond. Sorry. The double bond C and N over here. Okay, first start with this one. Well, what's carry nitrogen? It's mean amine. So it's have 1 bond, 2, so it need another one. Just add hydrogen in this one. For this one, it breaking out from this part, but it come from carbonyl compound. So it's mean that this one will be double bond here. Okay, because this one is connect to N. So what's connect to N mean that it used to be sp2 carbonyl carbon before with no double bond. You have to get rid of double bond to get the original compound. So when these two react to each other, it will form enamine. Okay, this is how to work out backward, not forward. Okay, can I move to next slide? Hope you get an idea of this one. Okay, so these are example of aldehyde and ketone react with primary or secondary amine. Okay, but in the book, if you are reading about condensation of amine with ketone and aldehyde, I didn't give you guys this slides, okay, but I think I should mention it, but it's not going to be in your exam or anything. But if you do like basic organic one, you have to remember all of this one. So the idea of this one is kind of like you have some other group of compound, not only R group. So we learn about amine, primary amine, to form imine or shift base, C double bond N. But you can have all sort of N nitrogen resources. For example, you can use ammonia. You can use something called hydroxylamine, hydrazine. We did this one to form dinitrohydrazine, okay? As long as you have this N, it doesn't matter which functional group over here, you will end up with imine, okay? And when you put a lot of water in it, it will change back to your compound as well. The important keyword is primary amine, okay? So it's a real organic chemistry, you have to remember all of that. But for us, we just use this two, okay, for basic organic chemistry. Okay. Right. So that is N nitrogen as a nucleophile. Okay. So I will move on to another one. Is addition of water. Sorry, alcohol. In this case, our nucleophile will be oxygen atom. The previous top section is N atom as a nucleophile, but this one is oxygen atom. Okay, so aldehyde and ketone react with alcohol, forming what we call acetal. Okay, so look at the equation. This is our carbonyl carbon adding to equivalent alcohol. It means two molecule of alcohol. You will end up with acetal. So what acetal look like? Again, this carbon is a previous carbonyl. It's been added by two group, so we call it acetal. Okay, so acetal is something of carbon with O, and this group, and this one group. But easy part to remember, just two oxygen attached to one carbon, we call acetal. Okay, because I'm asking you all the time because we have a lot of carbon that attached to oxygen atom. Okay, and we will learn about this later. And again, because alcohol is not strong nucleophile, we need acid. Okay, within this case, we usually use para toluene sulfonic acid. Okay, THOH, this is base. Sorry, this is acid. It's easy to use because this one is solid. You just sprinkle like a salt in it. So it's easier than another type of acid that usually dissolve in water. Okay, this one it's a solid one. Okay, let's see how it's formed. For this one, for example, we have aldehyde. We have, remember, alcohol, ROH, but when it's adding as a red color, it go like O and R together. Two equivalents mean that two molecule will be added, and it's called acetal. Another possibility, you have one equivalent, one mole, but you have two hydroxy position. It's also possible as well. It also form in this term called cyclic acetal. Again, this is carbon, our carbonyl carbon, attached to one oxygen, but they both join with two carbon, so it's still acetal. Okay, so this is a structure of what we call acetal. Okay, let's have a look at mechanism of this reaction. We divide it into two parts. Okay, so first part will be something about first alcohol. Okay, so start with protonation of oxygen about. Remember that our alcohol is weak nucleophile. So acids react first. So oxygen carbonyl protonate proton forming hydronium ion oxygen with positive charge. Two electron, not lone pair, just pi bond electron delocalize up to oxygen forming positive charge molecule. Now, based on neutral and charge molecule, this one become more active. So our first alcohol then forming bond with this cation. Okay, and again, because oxygen on alcohol is neutral, after forming bond over here, the oxygen itself become positive charge on top of oxygen. So you have, for example, if in water, anything that have lone pair electron or something else. Okay, so it will protonate proton. Electron move up to oxygen to form neutral alkoxy group. And this one we call hemiacetal. It means it's not acetal yet, but it's in the middle. And only one group being adding into it. So it's intermediate. Okay, hemiacetal. Okay, so this is already write down in your slide. Sorry, I forgot to tell you guys which page of this one. Sorry. Can anyone tell me which slide number? Slide 33. We're jumping a little bit. Okay. Thank you. 33, 34. Right. The second part, what happened? Remember that, well, unfortunately, we jumped from alcohol and phenol topic to this one first. So I'm gonna give you an idea and we will come back to alcohol chemistry later, okay? So for now on, just remember that hydroxy group is active in acid condition. So it will not stop if it still have proton in the solution. So for this one, it's already stable by R group, so it's become less active. So it won't react that easily in acid. But this one still active, so it will protonate proton from acid again, forming good living group of water that's ready to break out. So it will break out. That's why we get another second time of carbonyl carbon that carry positive charge. Then the second alcohol move in. Again, oxygen become positive. Then we have any water molecule or negative charge reactant taking this hydrogen, return to electron to oxygen to form neutral one at the end. Okay, that's why we get acetal. Again, acetal is a masking agent, but oxygen type, because when you put a lot of water in acetal solution, it will change back into carbonyl and alcohol. Okay, so it's two type of masking reagent. So it's called hydrolyze, which is react with water. Okay, remember imine and enamine also hydrolyze back to starting uh, compound as well. Okay, so this is example that I try to explain to you before. For example, I have compound A that have two functional group, carbonyl and ester. And I like to do some reaction, which is reduction. In the reduction, the products with no masking agent, this is the products that I want. Reduce at number 2 position. Okay, but this is what I get. A is the one that I want, but B is the one that I get because carbonyl is more active. Number 1 is more active than number 2. Okay, but what I'm gonna do, I want products A. Then we start with masking it, MASK, by react with alcohol. It will form, remember, acetal. And then you can use this product to do a reduction. So because this one's been cover or masking, only this functional group is available. So you will learn about this reducing agent or ester again. So only this one will reduce to hydroxy group as you wish. And then we add a lot of water. This one will change back to carbonyl. Here you go. This is the idea of masking reaction in real laboratory work. Okay, so we have two types, N-nitrogen masking reagent and oxygen. Okay. Okay, just try to do this exercise, please. 2 minutes, both. Hey, some of your friends already suggest some answers. Okay, so these questions asking, please label It's mean identify which one is an acetal, hemiacetal, or an ether. Okay. We're gonna learn about ether later in topic of alcohol and phenol. But ether mean oxygen that bond with two different carbon. Okay, so in this case, it's look like acetal because they have two alkoxy group, methoxy group, but it's located in different carbon. So this one will be ether. Okay, this one have two methoxy group attached to the same carbon. So it definitely acetal. Okay. This one, it's O something something. This one, it's O something something. So we consider it as a 2OR group in the form of ring system. But oxygen itself is still bonded to the same carbon or one carbon, so it's acetal. Okay. The final one, this is two O at the same carbon as well, but this is one alcohol. And this is hydroxy group, so it's hemi-acetal. Okay, so you have to remember this one. The second question's asking about what's carbonyl compound and alcohol that react to form these three compounds. So I should put water, like not here, this one. If you put a lot of water, which compound gonna be? And again, you need to label it, which type of molecule. For this one, you see two oxygen forming a bond with one carbon. So it's definitely acetal. Okay. This one, this oxygen attached to one carbon, two carbon, so it's nothing to do with this carbon. This forming something else, but this carbon attached to one oxygen to oxygen. So this area definitely acetal. Okay, so this one is ether feature. So we're gonna concentrate on this position only. Again, this one, O methyl attached to the same carbon, so it's definitely acetal. Now we have to work out, so it's quite straightforward. Just cut between this and form and OR. It's not a normal compound because oxygen needs two bonds. You just put hydrogen back on it. Okay, right. Let's have a look at this one. Okay. CO bond, CO bond. Mhm. And you know that it's carbonyl compound. So you put double bond O. This one has to be alcohol. You put hydrogen back to form a neutral. Okay. Second one, First cut. Second cut. There you have one and two. The second one is quite complicated because you have one alcohol. The second alcohol actually inside or in the same compound with carbonyl. Okay, so it's form first hemiacetal, and then the second one react later. Okay, for this one. Third one is quite easy, straightforward. O methyl two molecule. Okay, so this is how we uh, think about when the acetals changing to carbonyl and alcohol, quite similar to imine and enamine changing back. Okay, you have to first be able to identify them. Okay, and the bond between them. Okay, if we have time at the end or next time, we can do more exercise. Okay. Okay, this oxygen nucleophile, okay, alcohol. We still have another reaction which is oxygen nucleophile as well, but it's in the form of water. Okay, it means that aldehyde and ketone react with water. And also you need catalyst because water is a weak nucleophile as well. You can do the experiment in acid or base. It will give you the same products, which is diol or hydrate, in which hydroxy group add into carbonyl carbon, the same one. Okay. For example, I give this example to you guys before. Formamide aldehyde react with water, forming hydrate, and we call it formalin. Okay, so let's see how's the catalyst helping you in base or basic catalyzed addition. Hydroxy group from base is a strong nucleophile, so it will react with carbonyl carbon straight away. And again, simple nucleophilic addition, 2 electron delocalize up to oxygen. So now oxygen carry negative charge. It will protonate proton from water and then become neutral hydrate. So the reaction is done. How about in acid? Well, acid is a bit tricky because the reaction starts at oxygen atom. Okay, oxygen protonate proton forming hydronium ion. Oxygen carry positive charge. 2 electron again moving up, leaving positive charge carbon. Then water can react with positive charge carbon quicker. And again, because water is neutral, it will end up with positive charge again. So no problem. Another water will protonate proton. Electron move up to form the same products. It depends. You have acid or you have base. Acid is quite a little bit complicated than base. Okay, right. So for hydration, it's quite straightforward. But the hydration gives you an idea that why Ajahn always said that when you use your compound from the lab, please put the cap back and cover it up because in the atmosphere we have a moisture or water. if you leave the lid open, the water or moisture can get in a formaldehyde. It's constant changing 99.9% to hydrate form. So the aldehyde in the lab that leave it open, it's not 100% carbonyl group anymore. It will react as an alcohol because it's in hydrate form. Okay. For acetaldehyde, it's about 50-50%. So in the flask that leave it open, you have carbonyl structure and alcohol structure as well. That's why sometimes when you observe the reaction is not quite clear because our bottle might contaminate. Okay, but you don't need to worry about acetone because it just only less than 5 0.5% of this one because as usual, ketone is less active than aldehyde, so it won't change that quick. So the one that we have to be careful are aldehyde. So as I mentioned about formaldehyde react with water from formalin that used to preserve the tissue for scientific reason. But nowadays, a lot of people using formalin to preserve mostly seafoods, especially in our Isan area, because we know we live quite far from the sea or ocean. So for seafood, it takes time, logistic to deliver. So to make it last long, okay, after a day traveling and also get into hot pot, some people may put a little bit or a lot formalin in it so they can sell like a week long, okay? Or some vegetable or even plant uh, that been sell. Some of you might notice that when in the shop, the plant look healthy because they use formalin of formaldehyde. But when you take the plant home and try to care of it, it never lasts for a week. Usually it's all die or new, okay, because it's been perked up by formalin preservative. So be careful about your หมูกระทะ how long it's been there and uh, they might put a little bit of formalin. Okay, right. So that is all about the reaction of aldehyde and ketone. I'm gonna give you 5 minutes break, and then we will start with the final section, which is preparation or synthesis of aldehyde and ketone. Okay, get up, make a move, let the blood flow into your brain. Okay, and we will come back in 5 minutes. Okay. Okay. Everyone back to the class. So next Tuesday, I will have a test for 2%. Okay. First thing, uh, this, sorry guys, this slide is in page 17 of the handout. Okay. Uh, so on Tuesday, we will have a quick test for 10 minutes for 2% about the reaction of uh, aldehyde and ketone. Okay. I did try the homework, but I'm not happy with it. So from now on, it's going to be a quick test in class instead. Okay. Or some of your friend asking, okay, because based on the first one, I don't think you guys aware that I give you for free and you didn't do a good job at your homework at all. So I'm not going to do that again. So just fair share between us. So I'm gonna do a quick test. Okay. Right. I have to wait for your friend a little bit because she or he might have a problem with the sound. Okay. Anyway, I will post in a classroom because today is only 64 of 80 people that turn up. Okay. So on Tuesday, first thing in the morning, probably I will wait until you are in the class for 10 minutes. Quick test, 2%. Okay. And I'm also once one more add up class as an online is fine. So please let me know you prefer Tuesday evening or Wednesday evening. Okay. And I think we will be able to finish in time with extra exercise. Okay. So today I will move on to the section that we usually start first. But in this time, I script it to the reaction for you guys first. So now we are going to talk about how to prepare aldehyde and ketone. Okay, so there are a lot of reaction that you can use and it's too many. So I'm going to give you just a few example. Some of them you already learned it, and I'm going to introduce one or two new one. Okay, so in my exam, the preparation of aldehyde and ketone will be within the lecture note, but please keep in mind that it's so many reaction that you can use in a book, okay? But I will limit to the minimum for you guys. So uh, first one, aldehyde and ketone can be synthesized from alcohol by what we call oxidation reaction. Okay. And because we script alcohol, so I have to introduce some idea of oxidation for you guys. And this slide already be in the alcohol topic. So you just follow me, but you can look at it later. Okay, it's not in your aldehyde ketone topics. Okay, so when we're talking about oxidation or uh, reduction, okay, in general chemistry, we usually follow the oxidation number, oxidation state number, but in organic compound, calculating oxidation number of carbon is not that simple. So in order to identify oxidation uh, reaction, we usually count the number of CO bond. If you have at the final products, if you get more CO bond or increasing of CO bond, we will say this reaction passing through oxidation one. Okay. Or maybe if the CH bond is reduced, so it means that it's oxidation reaction. Okay, so when talking about oxidation reaction, you need to remember oxidizing agent because it's adding oxygen. So oxidizing agent usually carry oxygen atom. Okay, so we have two types of oxidizing agent. First one, it's oxygen bond. This slide is in another topic. Okay, so you can look at it later. First one, oxygen bonds mean our oxygen gas, ozone, hydrogen peroxide. So they have a lot of oxygen in it. Okay. Peroxide, oxygen bond, peroxy acid. This is another type. The second one is oxidizing agent with metal and oxygen. And you did learn about sodium dichromate, potassium dichromate, potassium permanganate, osmium, or even silver oxide. This is oxidizing agent as well. It's source of oxygen because it have 4 oxygen in it. Or this one, chromium oxide or pyridinium chlorochromate, or the abbreviation of PCC. This one and this one usually are strong oxidizing agent. When we have strong oxidizing agent, it will react very aggressive and you end up with the final products. But if you want the condition to be milder, not so strong, you can use a weaker oxidizing agent, usually PCC. Okay, the active oxygen containing is chromium. Okay, but when you put some bulky structure in it, it makes this chromium become less active. Okay, that's the reason if you put a bulky group or something that's have a steric effect, the reagent will be weaker or less active. Okay, this is just introduction of oxidizing agent. Okay, so now move back to preparation. We are using oxidation of alcohol. Okay, I did tell you about the type of alcohol. We have primary, secondary, and tertiary. Okay, at the milder condition, alcohol can be oxidized to form aldehyde. Okay, and the secondary alcohol oxidized to form ketone. Okay, so this one was primary. You just look at this carbon that attached to hydroxy group. If this size carry only one group or one carbon, then it's primary alcohol. Again, this carbon attached to oxygen, so it's important carbon. Then we count group. If it's 2, it means secondary. Okay, as you learned before, tertiary alcohol, it's uh, the oxidation is not occur in tertiary alcohol. That's why when you put sodium dichromate or potassium dichromate, it's remain yellow. It's not changed into bluish color thing. Okay, so how to draw a structure? You just have to concentrate on the carbon that attached to oxygen. So this one will form a carbonyl group. So the previous carbon will form carbonyl group. Okay, and if you have extra hydrogen, you have to count is it 4. Remember, carbon, carbonyl, you allow only 4 bond. Okay, if you have extra, just get rid of hydrogen. Okay, like in this one, if this one gonna form carbonyl, then you have to get rid of 1 hydrogen. Only 2 group will be here. Okay, so this is what we're gonna learn late in later topic. Okay, so I'm just give you guys an example. Right, can you predict the products of this reaction for me, please? 1 minute. Taking your compound type of alcohol. Oxidizing agent, weak or strong? Product, which carbon will be changed? Okay. Number one, which types of alcohol in number one? Can anyone tell me? Can you guys work out all three? Which type of alcohol in all three question? Okay, we have first answer from your friend. Primary, secondary, and secondary. Okay, anyone else? This is important carbon because it attached to hydroxy group. Important carbon attached to hydroxy group. To work out this carbon attached to one carbon, which is this whole one R group. So it's a primary alcohol. This one, the other hand, because it's ring system, so it's two carbon, secondary alcohol. Okay, this one again, one carbon, two carbon, secondary. Okay, oxidizing agent, PCC, it's a weak one. Okay, strong, strong one. Okay, so write down. You know that this carbon definitely gonna form carbonyl. Just write down carbonyl. Okay, but our starting material has two hydrogen. So during the mechanism, one hydrogen will be eliminated. But I ask you to just predict the product, so you have to keep one and get rid of one. Counting 1 bond, 2 bond, 3 bond, 4 bond. That's it. You cannot keep another hydrogen because it will form 5 carbon bond, which is not exist. This is how to predict the products. Okay. How about second one? Second one's quite straightforward. This important carbon. Okay. Third one will be this one. Okay. This is a first example of how to synthesize aldehyde or ketone by alcohol. Okay. And second method that you can use, I choose alkene because you learn about alkene chemistry already. So oxidative cleavage of alkene by ozonolysis, which means that it react with ozone, can break alkene double bond. Okay. What happened? You guys still see my slide? Is everyone here? Okay. My heart dropped because it's freezing. It's mean that we gonna finish soon. Okay. So uh let's finish this one before your brain is explodes. Okay, my brain as well. Right. I think something wrong with my tablet. Bear with me a few moments. The internet is very bad. Okay. Something wrong with my tablet today. So I think I'm going to finish off today if you don't mind. You okay? Okay. Right. Sorry, guy. It's not allowed. So tomorrow, not tomorrow. Remember Tuesday. 10 minutes quick test about reaction, not preparation, okay? Just reaction of aldehyde and ketone. Probably predicts the product or starting material or reagents for 2%, okay? And also please let me know that which day next week, half full online class that you prefer on Tuesday or Wednesday. And sorry about hiccup. So I'm gonna finish the lecture today and see you guys on Tuesday, half 10. Okay. So thank you, and hopefully it's not raining, and we can have a test all together. Okay. Bye bye. Have a nice weekend. See you next Tuesday.